So the instruments that are displayed in front of you are the two traditional methods of determining ESR and Paxil volume. But nowadays we have automated methods. But in order to understand the principle behind the erythrocyte sedimentation rate and Paxil volume, these two instruments is used in the academics. Out of these two instruments, both works on the same principle only, but this is much more sensitive as compared to the one which is the backside. Okay, by the way, this instrument is called as your WESTERGREN'S method of determining the ESR, or WESTERGREN'S pipette with a stand. Okay, and that is called the WINTROBE'S tube with the stand. Okay, this is much more accurate or sensitive in determining the values. Okay, so let's learn about the instruments one by one. First of all, so let's talk about the WESTERGREN'S instrument. So this is called as the WESTERGREN'S pipette. Okay, WESTERGREN'S pipette with the stand. So this is the stand and this is the pipette. Let's talk about the pipette first of all. Okay, why it is called pipette? So the main difference between a tube and a pipette is that the pipette has both ends open. Okay, so you can see the both ends. This is open end. Okay, as well as this side also is open end. So in school level you might have that titration. So titrating pipette, you must have heard about the word. So this is the same thing only. So whenever a pipette is mentioned, that means that instrument has both and open. Whether, and if somebody is speaking about test tube, so it's a tube, so that's a one end, so it's a blind end instrument. Okay, so this is an open-ended instrument. Okay, so this WESTERGREN'S pipette is an open-ended tube with the length of 300 millimeters. So if you do the measurement, okay, from the bottom to the top part, okay, you will get the measurement in 300 millimeter, or it can say to be 30 centimeter length. Okay, so if you take the cross section of it, you take out the cross section, or you take the measuring tape and try to measure the diameter of this pipette. So this open end pipette will be 2.5 millimeter in diameter. So if you look closely, you will see the tube, this pipette is graduated. Okay, is graduated in the lower 2/3. Okay, so the lower 2/3 of this pipette is having graduated markings. Okay, the upper 1/3, the name of the brand is given, or the glass is given. Okay, the lower 2/3 of this is measured, and it is measured from 200, so 0 to 200 millimeter. The distance is having the graduated marking. Okay, the values that are given over here is, obviously we are doing the ESR and PCV volume, so obviously these values are in the volumes of in the graduated volumes. Okay, now each of the division are signifying, if you look closely, each of the divisions, okay, it's not visible from here, let's see. Okay, not visible from here. Yes, now each of the division that you can look closely is consisting of 1 millimeter, sorry. So take for example this one. Okay, it is showing you 80. That means coming from the top, this is 0, then we have 20, then we have 30, 40. So in between the markings are missing. Okay, the odd number markings are missing. Sorry, not the odd, the alternate 10 decimal point 10 points are missing. So take for example this 80 to 100. Okay, so in between we have the 90 markings, so 80 to 90. If you can count, there are 1 2 3 4 5. So this is nothing but the 85. Okay, and this 1 2 3 4 5. Okay, so 80, 85, then comes the 90, 95, and then 100. So from 0 to 200 milliliter, the lower 2/3 of the pipette is marked with the volume graduated markings. Okay, so while we are doing the experiment of supposedly erythrocyte sedimentation range or the packed cell volume, what we do, since this is an open-ended pipette instrument, so we dip the other end, grabbing hold of the upper end of the pipette, we dip the other end of the, or the distal end of this pipette inside the blood volume or the blood diluting fluid or anticoagulant fluid mixture, and we drop the fluid, okay, by either sucking the this end and drawing the blood up till the zero marking, okay. So then after that we just grab hold, since this is open end, so if you just drawing the blood and you just leaving it, what happens, the gravity will push the blood and it will eject out all the blood. So immediately when it has reached the zero marking, okay, so we negate the effect of the gravity and we keep the blood volume that is entrapped inside the pipette fixed, okay. Now immediately when you have done this step, you have to keep it in a rack, okay. So the rack for the Western Green pipette is Western Green's rack, okay. So what we do in this rack, if you look closely, there are some slots given, okay. These slots are called as your rubber pads, okay, at the bottom part of the, so this is the base of the Western Green's stand, okay. With the base we have two vertical stands, okay, which is giving support to rubber pads, okay. The rubber pads are helping to cover or creating an airtight seal of the lower end of the pipette, okay. So supposedly you have entrapped the blood inside, you hold the upper end and you bring it and place it firmly on the base, that is the rubber pad, and you gently, so this rubber pad has a clip mechanism, so whenever you are pressing it, it goes down. So as it goes down, the distance increases and you easily slide the pipette and it is easily entrapped inside this in this slot, okay. So this is the Western Green method of determining ESR or packed cell volume. If you are doing an experiment with for the ESR, so we usually use the anticoagulant called as sodium citrate, preferably 3.8%, and conduct the experiment. Moving on to the next instrument for our discussion is the smaller instrument. I'm keeping these two instruments together to make you familiarized with the different features of this instrument. Although these two instruments looks the similar one, you can see the obvious difference between these two instruments. So this instrument for you is called as your WINTROBE'S tube with rack. So in this instrument we used a tube, not a pipette, as you have seen in the last video, that last part of the video, that is, this is called as pipette because we have two open ends of this glass instrument. But this WINTROBE'S, as compared to that of this, it's a very thick glass instrument having a smaller size as compared to that, and also one end is closed, one end is open, okay. So that's the distinguishing feature. And also the length of this tube, that is the WINTROBE'S tube, is 0 to 10 cm. It's approximately 11, so exactly when the manufacturer makes it is 11 centimeter, but just the bottom half from below to up, there is some graduated markings over here. So you can see the bottom marking is 0, and after every 10th marking we are getting an value of one individual number 1. Then after every 10 we are getting 2, 3, 4, 5, 6, 7, 8, 9, then we have 10. So the graduated markings are given from 0 to 10, but as a whole this glass tube's length is 11 centimeter. So it's a very thick walled. Okay, if you can compare, you can see over here, it's very thick walled. Okay, so as compared to that of the pipette, you can see it's a very thick tube. Okay, and whenever you are holding it, it feels heavy. Okay, this is a thick walled cylindrical tube with 11 centimeter length, and the bottom half of this and the two-third, more than two-third basically of this tube is with graduated with the marking, and the markings are from 0 to 10 from bottom to up. Okay, if you take the cross section diameter, it is 3 millimeter cross section diameter of the open end only. Okay, so interesting point to note over down over here is that this tube has two markings. See, the yellow color marking is showing you the values from 0 to 10 from bottom to down, and there is another marking named colored in red. Okay, from 0, then after every 10th marking it is using the marking of the yellow color shade only. So you can see 2, 3, 4, 5, then we have 6, 7, 8, 9, 10. So you can see there are two markings, and both of these are in opposite direction. So one in red from 0 to 10 from up to down, and from yellow the markings are 0 to 10 from down to up. Okay, so this is the Wintrobe's tube for you. Okay, so obviously you are going to do this use this tube for not only for ESR but also for the Paxel volume experiment. Okay, so for the ESR, what we do, we use another interesting pipette. Okay, so it's a very thin board. Okay, so it's a very narrow board tube. So a usual dropper or any instrument you own, or easily available instrument, you won't be able to insert the solution that you're going to do is keep it inside this tube. So we need a special instrument called as the pasture pipette. Okay, it's a very thin nozzle dropper with the help of which we take the solution, or the in this case blood volume, and we insert it right starting from the bottom. We insert the tip part of the nozzle at the base of this tube, and we withdraw the pipette we squeeze the pipette as we are withdrawing it out from the tube. Okay, so as you have kept this blood volume, whether you are doing ESR experiment or the Paxel volume experiment, you then have to place this tube in a rack, just like the WESTERGREN'S pipette. There was a WESTERGREN'S stand. So for Wintrobe's tube, we have a Wintrobe's stand. Okay, so the Wintrobe's stand also has a base with some slots. Exactly 6 slots are there. There are 2 vertical pillars over which the upper end of the rack is kept fixed. Okay, but the distinguishing feature between the WESTERGREN'S and the Wintrobe's is that there is no rubber cushion in the base. Okay, there is just a depression, a concave depression is there, over which we are just going to use, because in this experiment we don't need to create negative suction pressure with the help of the thumb. Okay, or there is no gravity effect as we open the ends, because this one end is already closed, so why do we need a rubber cushion? Okay, so we place the tube is kept in the slot, in any one of the slot, and we observe the experiment. Now I've told you in this tube there are 2 markings, one from bottom to up, another from up to down. Okay, so why is there? Okay, so this WESTERGREN'S pipette is used just for the erythrocyte sedimentation rate. That means when you are keeping the blood volume filled up till the upper marking, that is a 0. Now as you keep the blood volume in the pipette standing for few hours, what will happen? The blood will gravitate down because of the phenomenon called as the rouleau formation. Now when this rouleau formation is occurring, the RBCs get stacked together on one over another, keeping the denser cells at the bottom part and the lighter components of the blood and the upper part of the fluid. Okay, and that determines the ESR for you. Okay, so from measuring from 0 to whatever value, that gives you the ESR in per hour or in 2 hour, whatever value you want to put. Okay, there also you can see there is a value which is similar to the Western green, that is starting from 0. The 0 is the red color marking, 0, 1, 2, 3, just like that. Western greens, the lowest marking is the top. So supposedly you are keeping this Wintrop's tubes steady or keeping stable for a few hours. What will happen? The ruler formation will also take place over here, and the blood will gravitate down. The heavier components will be at the base and the lighter components will be at the top. So depending upon that, you measure the ruler formation in millimeter, okay, and you report the writings. Okay, that's the ESR for you. The same thing, the same tube. Now in this case, the same tube can be used during the same period for doing the packed cell volume. So during this time, the blood will be gravitating down, and packed cell volume definition is the number of cells that is the cellular components in the blood which is getting packed together during a certain in the interval of time. Okay, so if you measure from bottom to up, you are taking this time the yellow marking. What will happen? 0, 1, 2, 3. So usually it has been seen a packed cell volume in a normal non-pathologic blood to be around 45%. That means uh, if you are checking the packed cell volume in this blood, you have to count the blood's volume from 0, starting from the bottom part. So 0, 1, 2, 3, you are going to use the yellow color marking. So if supposedly it has normally you are taking a normal blood with no pathological condition, so approximately you should get the blood to be stagnated around 4.5. Okay, for interpreting the result, what we're going to do in this Wintrop's tube, you have to multiply by 10. So supposedly you are getting 4.5, you multiply 4.5 with 10, and you tend to get the value called as the packed cell volume with the help of the instrument called as Wintrop's method. Now the blood samples, as I've told you, in case of the Wintrop's WESTERGREN'S pipette, the instrument was the blood was used mixed with the sodium citrate 3.8%. But in case of the Wintrop's tube, the blood samples are mixed with ethylene diamine tetraacetate. Okay, blood is mixed with that or double oxygenate solution. Okay, so we keep this blood in a anticoagulated form and then we conduct the experiment.